Hello biology students, and welcome to video 2 of the inorganic chemistry unit. So I want you to remember back to video 1 in this unit, where we talked about the fact that electrons are found in the energy levels or electron clouds surrounding the nucleus in an atom. So I want to talk about a little bit of that in more detail. So here we're going to define energy levels as the region in the electron cloud where an electron is likely to be. So in other words, each of these rings here, it's not like the electrons orbit the nucleus in a set ring. These electrons can really be found anywhere outside the nucleus. They're just most likely to be found in these rings. Okay? So each ring, the first ring can hold a maximum of 2 electrons. The second ring can hold 8. And for our purposes, we're going to say that the third can hold 8 as well. There are more rings after this, but we're just going to follow this rule. And the last thing you should know is that electrons fill the rings from the inside out. So for example, if we had something like lithium, the symbol is, is Li, and lithium, the atomic number is 3. Which means that it has 3 protons, but it also means it has 3 electrons. So because they fill from the inside out, the first 2 electrons will go in the first ring, and then the third electron will go in the second ring. Okay? So this kind of model of drawing an atom is called the Bohr model. It was invented by a guy whose last name was Bohr. And the way this works, that is you draw an atom, you draw a center circle that's supposed to represent the nucleus. In that center circle, you write how many protons there are and how many neutrons there are. And then you place the electrons in the appropriate ring. So if you look at your periodic table, carbon, atomic number is 6, and the mass number is 12. So that's how we know we have 6 protons and 6 neutrons. So 6 protons coming from the atomic number, and 6 neutrons coming from 12 minus 6. And we also know because carbon is neutral, it's also going to have 6 electrons. So the first 2 of those electrons go in the first ring, and the other 4 are going to go in the second ring, because the second ring can hold up to a maximum of 8. Similarly, oxygen, which has 8 protons and 8 electrons, here the first 2 are going to go in the first ring, but now in the second ring we're going to have 6 to bring us up to 8. So the next thing I want to introduce is the idea of the octet rule. And what this states is that atoms are most stable, and by the way, this box was supposed to be a cute little smiley face, but it translated weird to my video software. So atoms are most stable or most happy when the outermost energy level has 8 electrons, okay? And by the way, the electrons in the outermost energy level we call valence electrons. That's just a special name we give to those electrons. So, if atoms do not have a full outer shell, if they don't have 8 electrons in the outer shell, they're unstable. So in order to become stable, they'll form a chemical bond with a different atom. So maybe they'll share electrons with another atom, or even take electrons from another atom in order to get 8, because they want to have 8 to be stable. So the exception to this rule are atoms like hydrogen and helium. They only need to have 2 electrons to be stable. And the reason for this is hydrogen only has 1 electron and helium only has 2. So if this is my nucleus and this is my first energy level, this first energy level only holds 2 electrons, right? So that level is considered to be full even though it only has 2. That level is never going to have 8. So those 2 guys are the exception to the rule. So, just to reiterate, if atoms do not have a full outer shell, they're either going to gain electrons, so maybe they'll take some electrons from another atom when they form a bond. Because in bonds, you can gain, lose, or share electrons. They can also lose electrons by giving one away, or they might share electrons. So let's look at a couple of examples. Something like hydrogen, right here, it only has 1 electron, as indicated by this blue dot in its outer shell. Remember, hydrogen is an exception, so it wants to get to 2 to be stable. So what it's going to do is it's going to either take an electron from another atom to get its second, or it might even give its electron away. Okay? Carbon, if you look, currently has 1, 2, 3, 4 electrons in the outer shell, and it wants to get to 8, so it has to gain 1, 2, 3, 4 electrons to get to 8. If you look at nitrogen, it has 1, 2, 3, 4, 5, so it needs 3 more. Now for nitrogen, what it's going to do is it's going to gain 3 electrons. In theory, it could also lose 5 because then it would be down at just the previous lower level. But it's a lot easier for nitrogen to gain 3 than it is to lose 5. Similarly with oxygen, oxygen would need to gain 2 electrons to get to 8 to be stable. Again, in theory, it could lose 6 and still be stable because it would have a full first shell, but that's not likely. That's energetically, that's way too difficult for it to do that. Okay, so we're going to look at the 2 main types of bonds, and then that will bring us to the end of the video. So the first types of bonds we're going to talk about are ionic bonds. And before we can talk about that, we have to know what an ion is. Because if you look at ion is right in the name of ionic bond. So an ion we're going to define as a charged atom. So I talked in a previous video about how most atoms we assume are neutral. They have no charge. They have an equal number of protons or electrons. But if you think, if that neutral atom gave away one of its electrons or took an extra electron, well, now the electrons and protons are not going to be equal anymore, so the atom will be charged. And when it's charged, we call it an ion. Okay? So then if I have 2 ions near one another, so say I have sodium. Now when sodium forms an ion, it becomes a positive ion. And if chlorine gains an electron, it becomes a negative ion. And now if I put my positive sodium near my negative chloride, that positive and negative are going to attract. And that attraction of opposite ions is called an ionic bond. Okay, so what I would get here is I would get the compound NaCl, which is table salt. And any compound with an ionic bond is called a salt. Okay, not just NaCl. Anything that forms an ionic bond is called a salt. Okay, so let's look at this a little bit more carefully. So you can see right here, I have sodium, regular old sodium. So not the sodium ion, the sodium atom. And you can see it has 1 electron in its outer ring. Now, remember, it wants to have a full outer ring. So it could either gain 7 electrons or give away 1. Well, it's going to be a lot easier for it to give away 1 than it is to gain 7. Similarly, chlorine has 1, 2, 3, 4, 5, 6, 7 in its outer ring. So it can either gain 1 or give away 7. And it's going to be a lot easier for it to gain 1. So what happens is this electron right here gets donated to chlorine. Okay? And now sodium is missing an electron, so it has a full second ring. And chlorine has gained an electron, so it has a full third ring. And because it lost an electron, it now has 1 less electron than proton. So it has a +1 charge. It's given away an electron, so it has an extra proton. Where chlorine has gained an electron, so it's gained a negative charge, so it has a negative charge. And this positive and negative attract one another, and we get NaCl. We get an ionic bond. So the other bond type that you're going to be responsible for are covalent bonds. So in ionic bonds, we were either taking or giving away electrons. In a covalent bond, 2 atoms share electrons. Okay, when these guys share electrons, instead of forming a salt like we do in an ionic compound, we're going to form what's called a molecule. Okay. So molecules can be drawn lots of different ways. Excuse me. So a molecule, you can write the formula, right, just like you might an ionic compound. You can also draw what's called the electron configuration. You can draw the atoms sharing their electrons. So let's look at a simple example here. So H2, right, so each hydrogen, I'll draw it down here, only has 1 electron. So there's my 1 hydrogen with 1 electron and my other hydrogen with 1 electron. Remember, they both want to get to 2 to be stable. So if, they share their 2, so they're co-owners of those 2 electrons, they both have 2 and they're both stable. So you can see in covalent bond we're sharing. Okay? And this would be a single bond because they're only sharing 1 pair of electrons. They're sharing 2 electrons total, 1 pair. Oxygen, remember each oxygen had 6 electrons. So if the oxygens share 4 electrons total, now this guy right here has 1, 2, 3, 4, 5, 6, 7, 8 in the outer ring. And this guy over here has 1, 2, 3, 4, 5, 6, 7, 8 in his outer ring. So they both have 8, but they had to share 4 electrons to accomplish that. So that's called a double bond. Okay. So double bonds have 2 pairs of shared electrons. And remember, by 2 pairs, I mean 4 electrons total. So some guys who have double bonds, carbon dioxide, if I drew carbon dioxide, the bond pattern would look like this, okay? Oxygen gas has a double bond. C2H4 has a double bond, okay? It will look something like that guy. And we can even have something called the triple bond. And a triple bond, we'd be sharing 3 pairs of electrons, so 6 electrons total. And an example of that is nitrogen gas. We have a triple bond right there. So that's video 2, and I'll see you in video 3.